The Charles Law was discovered by Joseph Louis Gay-Lussac. At constant pressure, the volume of a given mass of an ideal gas increases or decreases by the same factor as its temperature on the absolute temperature scale. A real-world scenario. A balloon filled with helium on a cold winter day. While you are in the shop, the balloon is normal. As you step outside, the balloon begins to shrivel up. This happens because of the temperature of the helium in the balloon decreases and becomes less dense. Because the helium particles lose energy and become more concentrated, decreasing the volume. But when you put the balloon in a warm area, it goes back to its original size. A hot air balloon floats because the hot air is less dense than the cold air around it. The law was named after scientist Jacques Charles, who formulated the original law in the 1780s. John Dalton demonstrated by experiment that all of the gases and vapors that he studied expanded by the same amount between two fixed points of temperature. Dalton was first to demonstrate that the law generally applied to all gases and to the vapors of violet liquids if the temperature was well above the boiling point. Boyle's law was discovered by Robert Boyle. Boyle observed that the product of the pressure and the volume are observed to be nearly constant. The product of pressure and volume is exactly a constant for an ideal gas. Real-world scenario. The popping of a balloon. When we try to squeeze a balloon, we are actually trying to reduce the volume of the gas inside, which increases the pressure. Since the balloon cannot withstand the added pressure, it bursts. Gay-Lussac's law was discovered by Gay-Lussac. When gases combine, their relative combining volumes and the volume of the product, if it is a gas, can be expressed by a small whole number. Real-world scenario. An example would be an aerosol can. If you expose it to flame, you increase the temperature quickly. Doing so increases the pressure because the molecules bounce off the surface of the container more often. The buildup of pressure can cause the can to explode, which is why there are warnings on such cans.